Hello, this is Mrs. Fries, and these are notes on Chapter 10, Lesson 7, Theoretical and Experimental Probability. I hope you are all doing well. I would love to hear back from you if you are doing the acts of kindness that are posted on the website, and just give me a little insight into how those are going for you. And please always email me if you have questions. Make sure you're watching all the videos that are posted because they will probably answer most of your questions, if not all of your questions. Okay, so let's talk about theoretical and experimental probability. Theoretical probability is mathematically what should happen. We did that yesterday when we did the notes on simple probability. Experimental probability is what actually happens when you do a probability event. So let's look at theoretical probability of rolling a 4, and then we'll do a little experiment to see if our experimental probability matches what mathematically says should happen. Okay, the probability of rolling a 4 on a die, we know there's only one 4 on a die, and there are 6 total numbers. That gives us 0.17 or 17% chance, mathematically, theoretically, of rolling a 4 on a die. Now let's do a little experiment and see if our experimental probability of rolling a 4 on a die matches our theoretical probability. We're going to use a die, okay? And what I'd like you to do is go ahead and build this table right here in your notebook. We know that the outcomes on a die are a 1, a 2, a 3, a 4, a 5, and a 6. So those are the possible outcomes on a die. And we're going to use our little die over here, and I'm going to set my timer for a minute. Okay, ready? All right, first roll is a 6. I'm going to put a little tally mark on 6. Second roll, oh, a 4, that's what we want. A 6, 4, a 3, a 4, a 3, a 5, 4, 4. Wow, 4 is really getting ahead here. 2, a 3, a 1, a 5, a 2, 6, 2, 2, a 5, and a 2. All right, time is up. Let's write how many times we rolled each number. We rolled 1 one time. We rolled a 2 5 times. We rolled a 3 3 times. We rolled a 4 5 times. We rolled a 5 3 times. And we rolled a 6 3 times. Okay, let's count how many times we rolled total. 6 plus 8 is 14. 14 plus 6 is 20. So we rolled 20 total times. Okay, let's calculate our experimental probability and see if it matches or comes close to mathematically or theoretically what we said would happen. In order to do that, we want to put the number of times a 4 was rolled. That's what we wanted to have happen, the favorable. So there were 5 times that we rolled a 4 out of a total of 20 rolls. Well, we know that is 1/4, and that is 25%. So experimentally, We rolled a 4 more times than mathematically was determined that we would roll a 4. Remember, this is just mathematically what should happen. Experimental doesn't always match that. So, theoretical and experimental probability are used to determine if a game is fair or unfair. So there are games that are set up so that they're fair to both players, and there are games that are set up that are more fair to one player mathematically than another player. Let's look at an example of that to see how mathematically we can determine if a game is fair or unfair. Okay, we're going to use this video. I want to get it to the place that has the fair or unfair game. Okay, and this video is posted on the website as well. Okay, here we go. All right, so you can see that mathematically some games can be set up so that one player has a better chance to win over the other player. We're also, after this video, we're going to go look at some other games and determine if theoretically they are fair or unfair. All right, last example, you'll have some problems like this on your homework. It says the table shows the results of a survey that asked 200 teens what they would be doing if they were not online. Imagine that, not online. Out of a similar group of 450 teens, predict how many would be listening to music. So if you look at the survey, you can see that 52 teens were listening to music. So 52 teens were listening to music out of a total, not the right spelling, out of a total of 200 surveys, okay? So this becomes our rate, 52 out of 200. We're going to use this rate to predict how many teens, okay, how many teens would be listening to music out of a total of 450. Again, this is only a prediction, but this survey gives us information that will help us predict how many would be listening to music out of 450. And of course, we're going to cross multiply. That gives me 200 times x is equal to 52 times 450. 52 times 450 is 23,400. We have to undo that 200 times x by dividing both sides by 200. And that tells us that 117 teens, we can make a prediction out of the 450, would be listening to music if they were not online. Okay? All right, so what I'd like you to do now is head on over to the video on fair and unfair. We're going to play a few games to determine if they were fair or unfair experimentally and theoretically. And that should help you with this concept even further. Have a great day. And again, I hope that we can be back in the classroom and I can be doing this in person with you in the near future.